So there's only one lane you can exit from.
All right, we're on page 275. And again, I'm going to have in my head what the graph of f of x looks like and what the graph of x minus 2 looks like. So those are my two graphs. State the domain and range of each of them. So in A, for A, the domain of my blue one is x is greater than or equal to 0, and the range is y is greater than or equal to 0. And for the green one, the domain is everything, and the range is everything. So it's nice to have those little graphs drawn up ahead. There's the green one. And then in part B, now we're going to do the dividing. It says q of x, and again they want to write this explicit equation. So f of x was the square root of x, and g of x is x minus 2. This is the explicit equation because it's just in terms of x. And now we want to find the domain and range of this. And this isn't something that we've done a lot of. So when we go to draw our graph, because the domain you could do without drawing the graph. So first of all, the domain is going to be, of this new one, I'll do it in purple. The domain is going to be x is bigger than or equal to 0 because it has to be where the two domains overlap. Because you can't divide two things if one doesn't exist. But it's also going to have that x can't equal 2 because on our green graph, or even you can see it in the equation, that 2 is a non-permissible value. So we can't have x equals 2. Now the range, this is going to be something that we would have to graph in order to get an idea of what the range is. So what do I know so far? I know that there's a non-permissible value that doesn't cancel at x equals 2. And from the rest of this, I would just have to find some points. Now, sometimes the equation that you get is something that you have graphed before, but we've never graphed the square root of x over x minus 2. So a very helpful thing that you can always do when graphing is do a table of values. So for example, when x is 0, y is 0. So that's going to tell me I have the point 0, 0. When x is 1, that's easy to do mental math, I get negative 1. You might be able to see that the only x-intercept is 0, so this is enough information for us to say that this is going to graph down like this. Next, technically you can say there's going to be an asymptote at y equals 0 because the degree on the top is a half and the degree on the bottom is 1. So whenever the degree was bigger in your denominator, we had an asymptote at y equals 0. If I plug in 3, what am I going to get? Well, maybe I'll plug in 4 because it's a nicer number. Square root of 4 is 2. I'd have the point 4, 1. and towards the asymptotes would end up like this. And our range is actually everything as well, even though it's broken up. Because 0 for y is possible at 0, 0. So on the exam, usually they're going to ask you only the domain, because the range can be a little bit tricky depending on the function. Questions for practice on this one are 6, 13, and 16.